Mrs. Crone did most of your worksheet problems that involve the conjugate, so instead of giving you one off your worksheet, I'll give you another example, and then that should help you finish up the other two on your worksheet. But before we go into it, let's just remember that when we were talking about polynomials and we were factoring them, we had a special case called the difference of square. So over here I've written a difference of square. It's when we had two terms and there was a minus between them, because minus and difference are the same, mean the same. So difference of squares, and x squared is a square, it's x and x, and 9 is a perfect square number, it's 3 and 3. And so if you remember, when we factored, we knew that it came from this pair of binomials, x, 3, 3, and 1 plus, and the other one a minus. So the values of the terms are the same, but the signs between are opposite, and that's how the middle disappeared. That's how we ended up with just two terms instead of the usual three. When we're dealing with the polynomials and we're factoring, we usually have 3, but the special case difference of squares just has 2. And so over here, when I'm dealing with radicals, and I've got a binomial in the bottom, and I want to rationalize it, I might think, oh, all this times by the square root of the radical, 2, like we've done before. But because of this 3 here, it's not going to work, because even though when I multiply my square root of 2 to my other square root of 2, I get square root of 4, which is 2, and I get rid of the radical, I also have to distribute him to the 3. And when I do that, I get 3 square root of 2. So I've got 3 square root of 2 plus this 2 in my denominator, and that didn't get me anywhere. I've still got an ugly radical that isn't okay to leave there. So instead of doing that, we think about the difference of squares, and we say, okay, so I got rid of a radical, or I got rid of a middle when I multiplied the same thing times the same thing, except that one was a plus and one was a minus. So I'm going to do the same thing over here and multiply by the same values in the denominator, except I'm going to do the opposite sign in the middle of it, so that I don't have any middle to worry about. And now I have to do the same thing to the top, remember, otherwise I'm timesing by something other than 1 and changing the problem. So now when I multiply, I get 3 and 3 is 9, and square root of 2 times square root of 2, one of them's minus, so minus square root of 2 times 2, so we get 9 minus 2. And I could multiply the other and do the middle terms if you want, so my 3 went to my 3, but my 3 also has to go to the negative 2, so that would be negative 3 square root of 2, and the square root of 2 went to the square root of 2, but he would also go to the 3, but notice that he's positive this time, and so they just disappear. It's not a bad thing to do it anyway and then see it disappear, because sometimes we mess up thinking it is a difference of squares and it's not, but I knew it was. That's why I quickly did the 3 to the 3, the first terms, and the last terms. And then we got 9 minus 2, which is 7. And so I can rewrite, make some space over here, I can rewrite my denominator as just 7. So we've got 7 in the denominator, and then on top my 1 multiplies to the 3, and I get 3. And he multiplies to the negative 2, and I get negative square root of 2. And I check and see, but there's no more I can do. The 3 and the invisible 1 and the 7 don't have anything other than 1 in common, so I can't reduce the numbers, and I don't have any other radicals to try and combine. So we are finished.